Hello Year 9. Today we are going to do about polymer structures. Polymer is a type of molecule and we're going to go into a little bit more detail today on the forces between those molecules and also how those molecules are made. So could you just write down the title for me please, and then write down a list please of as many words as you can think of that start with the prefix poly. So poly and then the rest of the word. Pause the video and do that, and when you are done you can press play again. Alright, so here are some words that I came up with that start with poly. So I came up with polygon, so a many-sided shape. A polypod is something with lots of legs. Polystyrene. Polystyrene is actually one of the polymers that we're going to be talking about today. Polygamy is when you're married to lots of people, and a polysaccharide is also a type of polymer, but it's lots of sugar molecules joined together. You might have come up with other words as well, and probably the start word poly as part of that word is referring to the same thing in all of those words. Poly means many. So if we have a polymer molecule, that polymer molecule has been made of many little molecules joined together to make a big long one. So here is an example for you. So polymers are very large molecules and they are held together with covalent bonds, just like water molecules or carbon dioxide molecules, but they're way bigger than that. They're not quite as big as the giant covalent structures that you did in the previous lesson though. Polymers are made by joining lots of smaller molecules together. Those smaller molecules are called monomers, and once they're joined together they make a big long chain like this. So this molecule that we're starting off with here, this is the monomer, and you need lots and lots of those. So that's the reason why they've put brackets around it and an N at the bottom here, just to be like, you need loads of these, and you join them all together and you end up with a big long chain. Each of these lines in the diagram here is supposed to be a covalent bond. So essentially it's just one really big long molecule. You can pause the video now and make some notes on what a polymer is. Okay, so when you've got a few polymer molecules, they end up interacting with each other. So in this picture here, it's showing 3 different polymer molecules, what they would look like if we made them out of molymod, like we have been doing in lessons. Now, covalent bonds are the bonds holding the chain together. So between the atoms in a chain, there are covalent bonds. Those bonds, if it say melts or boils, those are not going to break. They're going to stay how they are, and this chain is going to stay as one polymer. There are intermolecular forces between the polymer molecules though. So the intermolecular forces, if you were to label them on a diagram, are going to look a little bit like that. I've done this as like a dotted arrow just to show that the intermolecular forces are weaker. So the molecules are attracted to each other, but they're not as strong as the covalent bonds. And actually, these molecules can slide over one another. They can kind of move around despite the fact that they've got those intermolecular forces between them. There are lots and lots of intermolecular forces because the molecules are really long. So if you had, for example, a water molecule, which I know we made out of molymod in real life, those covalently bonded little molecules, they're really small. And so the intermolecular forces between small molecules, they're not as strong. Whereas in polymers, the intermolecular forces are stronger, or there's more of them because the molecules are really long. So if you could just again pause this for a second, do a little diagram and label it with intermolecular forces and covalent bond, that'd be amazing. Okay, so let's see if you're ready for a question. Polythene is an example of a polymer. It's a solid at room temperature rather than a liquid. Can you try to explain why? And try to use the word intermolecular forces in your answer, please. Pause the video, answer the question, and I'll tell you the answer in a second. So the reason why polythene is a solid at room temperature is because it's being held together by intermolecular forces. But because polythene has such long chains, those intermolecular forces are stronger than in a smaller molecule. So that means that polythene is going to be a solid. Okay, do any corrections that you need to your answer, and let's move on. So, here's the thing. Some polymers, rather than just having those intermolecular forces, they also have these things called crosslinks between the chains. The crosslinks are stronger than intermolecular forces, and what this means is that they're going to be rigid structures and the molecules can't slide over each other so much because these crosslinks are stopping them from moving across each other. You can stop this here and do the diagram and make some notes. Okay, so again, a couple of questions for you. Number 2, how does a polyethylene bag stretch if it's got lots of shopping in it? And 3, why do you think the polymer melamine, which is used to make things like plates and bowls for camping, why do you think that that polymer can't stretch and is rigid? I'll tell you the answers in a second. Okay, so the answers to those two are, for number 2, the intermolecular forces are relatively weak in polyethylene. Therefore, the chains can slide over each other. So the important phrase in that answer is the fact that the polymers can slide over each other for number 2. And number 3, in melamine, there are crosslinks between the strands of polymer. So that means that the molecules cannot slide over each other. That picture there, it's going to look very, very similar to this one, except the difference is that on the polymer that you're going to draw, there's 1, 2, 3 hydrogens on the molecule, but then there's also a chlorine attached to that molecule as well. So see if you can draw the polymer that you think that is going to make. Pause it and I'll show you what it looks like in a second. Okay, so the polymer is going to look like this. It's going to have a load of carbons joined together in the middle, hydrogens all along one side, and then on one side you're going to have alternating chlorines and hydrogens, and that is what that particular polymer is going to look like. So you get a different polymer depending on the monomer, the little molecule that you start off with. Okay, this is the final thing that you need to know for this lesson, and it is for higher tier only. I know that you haven't chosen your tiers yet that you're going to do for GCSE. However, if you do higher tier, you need to know this information. So, condensation polymers are made using 2 different molecules. So, as opposed to the last one, where it was just one molecule repeated, this one, you're going to end up with 2 monomers joining together and essentially alternating to make a big long chain. So in this picture, you can see that the triangle is supposed to be one monomer and the circle is supposed to be another monomer, and they're joined together to make a big long chain. It's just that they're alternating between which one is next. When a condensation polymer is made, you also get a water molecule being made as well. You're going to do this in way more detail when you get to C6, which will be in year 11. Okay, final question of the day. Terylene is a polymer made from benzene 1,4-dicarboxylic acid and ethane 1,2-diol. It has a relatively high melting point. Now, I bet that you just heard that and you were like, what on earth is benzene 1,4-dicarboxylic acid? What on earth is ethane 1,2-diol? And that is probably what the examiner is thinking that a lot of people will respond like. Now, when you get a question like this and it's got chemical names in and you're like, I'm not quite sure what that chemical is, the first most important thing to do is to not freak out about it. Then we need to deduce what information we have been given. So we have been told, first off, that it's a polymer. We know what polymers are like. We know that they're made of long strands with relatively strong intermolecular forces. It's also telling us that it's made from this monomer and this monomer. So it's made of two different monomers, and it's telling us that it's got a pretty high melting point. So rather than worrying too much about what these chemicals are, the only thing you really need to know is the fact that there is two of them, and that's important for answering the question. So there's part A and B here. You only need to answer these if you are going for the higher tier, or if you think that you're going to be going for the super high grades when it comes to the GCSE. So this is essentially like an extension question. So A, could you explain please whether you think that this is a condensation or an addition polymer? And B, could you suggest why you think it's got a relatively high melting point? Pause the video, answer the questions, and I'll tell you the answers in a second. So the answers are, for 5A, it's a condensation polymer because it's made of two different molecules reacted together. And B, it's got a relatively high melting point because the intermolecular forces are relatively strong. And that's it for today, Year 9. I will be setting Easter homework, and please expect that on your Google Classroom at some point very soon. If you could please either take a picture of your notes from this lesson, or if it's on a Google Doc, it's obviously on the internet already, and could you please put your work from this lesson in the folder that you made previously. I'll talk to you later. Bye.